Hi there, this is the start of the section on the Pythagorean theorem. This video is going to deal with just vocabulary and labels so that later on when I use specific words, you'll know what I'm talking about. All right, first of all, there's two basic types of, two categories of triangle words. One of them is ones that are based on the lengths of the sides of triangles, and the other one, you can see down here, is based on the types of angles. So let's get started. If we're talking about the lengths of the sides, there's basically three choices. Okay, you can have an equilateral triangle, an isosceles triangle, or a scalene triangle. Now, I think you can guess what this means. Look at that word, equi. That, I hope you recognize, sounds an awful lot like, come on, say it. Equal, yeah. And lateral means side. And it tells you right there exactly what it is. It is all the sides are exactly the same length. And this is, I can tell right now, it's going to be horrible because I'm going to try and draw it. So if I use a ruler or something like that, those sides would all be the same length. Now, because I'm sketching, one of the things mathematicians do to be, I'm going to say more accurate, I wouldn't want to say lazy, is I can put a little tick there and a little tick there and a little tick there. And that says, without even having to work too hard, that those three sides are all exactly the same length. And the weird thing is, see how well I can do here. When you draw these, they all kind of look the same. They're like the normal triangle you think of if it's not a right triangle. Now, notice I used two little slashes there. I didn't want to use one slash because then they might think that it's the same length as that. But all three sides are the same length. Easy peasy. Now, isosceles triangle, two of the sides are the same length and one's a different length. They're all three the same. Back to there. I probably could have just used one slash because it's in a different box, but that's okay. So I'm going to put one down there. So these two sides are the same length. This one's an oddball. But you can also have an isosceles triangle. Ooh, my drawing's a little, oh goodness, my bad, sorry. Okay, first of all, right there, that says it is a, tell me, yes, a right triangle. And then I can do this and that and show that those are the two sides so that it's the same. You can even do a triangle like that. It doesn't have to be a little angle or a 90-degree angle. It can also be a bigger one. I don't want to use the fancy words because they're showing up here at the bottom. Okay, now I'm starting using the different slashes, but you get the idea. Now, a scalene triangle, all the sides are different lengths. And it can be a right triangle, one that looks like that. So you have 1 and 2 and 3, showing all three different sizes. It could be that one's starting to get a little iffy, but I tried to make them all different lengths. Okay, I'm going to stop with the slashes because it's going to look weird. And again, it can even be one of those. I don't know, I think of them as like wide triangles. As long as all three sides are different lengths, that becomes scaling. Oh, you know what? I'll do 1, 2, 3. Okay, but you get the idea with the little slashy bits. Okay, ta-da! There you go. That is how you talk about them. Equilateral, 3 sides the same. Isosceles, 2 sides the same. And scalene, no sides the same. Or all the sides are different lengths, however you want to say it. There is a second bunch of vocabulary that we can use, set of vocabulary, based on the types of angles. Actually, probably should have said the measure of the angles. All right, so an acute is an angle where all of them are less than 90 degrees. So there, all of those are less than 90. Remember, 90 degrees is a square corner. But maybe you're going, wait a minute, you just drew that same triangle up there. It can be. You could think of this, the lengths of the side as a descriptor of hair color, and this talks about eye color, and they don't always have to match. So everything is less than 90 degrees. So I'll try and draw a scalene one here. Oh goodness, I shouldn't be so cheap. I should go find a ruler, but you guys get the idea. So all the angles are less than 90. That is what acute means. And forgive me, but I always think, oh, there's a cute little triangle. They're just like a baby. They're a cute little triangle or a cute little angle. Sorry, it's how I remember stuff. All right, a right triangle is easy. You guys have done that. It's got a 90-degree corner. It's got a nice square corner. And there's limited ways that I can draw 90-degree triangles. And to show you it's a 90-degree triangle, you make sure you put the little box in the corner. That's what that means. That says, yeah, whatever this picture is, even if you took a protractor and measured that at 89 or something like that, I meant it to be a square corner. I can draw it this way. Okay, there's not a whole lot. I don't know. How about, ooh, check it out. I should stop. I should have made you do this. Oh, that one looks horrible, which is why I like drawing in the square corner. Okay, so that's a right angle. And it's only going to have one right angle, just one. Okay, can't have more than one. And at some point with triangles, we'll explore that. An obtuse triangle is one where one of your angles is over 90. And that's what I was drawing up here. And I was calling them wide triangles. The right word is obtuse. Okay, so this one here. Basically, it's more than a square corner. Okay, cool. So let's say we'll put a little room down here. All right, I'm going to draw. No, you are going to draw. Start out by drawing an acute scalene triangle. So you got to keep two things going on in your head. One is the idea that all your angles are less than 90, and the scalene is telling you that all the angles, sorry, all the sides are different lengths. Give it a shot. I'll wait. Now I'll make this one a little bit longer. And I'll do about there. Yeah. I don't know. If I was doing this for an assignment or something, I would make sure that there was a big difference there, because those two kind of look the same length. But I'm going to do that. If you had to hand something in, I would ask you to use a ruler to draw it nice and straight. This, I'd probably go at it with a ruler myself and just measure it. All right. How about a right isosceles? All right, so I knew I need a square corner. Now I'm going to make this side and this side, those look about the same length. And then I draw across like that. And I can mark them. There we go. Now, I was thinking about doing an obtuse equilateral, but that doesn't work. Because the moment I draw this obtuse part, I'm not going to be able to make this side the same as the others. I'm going to challenge you to draw right now. Draw a triangle. By the way, that's just me being lazy. Triangle with 2 right angles. Okay, give that a shot. Well, there's my first right triangle. But what happens when I draw the second one? Well, you know what? It doesn't matter whether you draw. Let's draw it up here. That is never, ever, ever, ever going to be a triangle. In fact, these 2 lines end up being parallel to one another. No, can do. That's why up here we can have exactly 1 or have 1 angle that's over 90. I'll give you a hint and I'll show you later on why, or an example of how this works, but all the angles in a triangle add up to, hopefully you know it's 180. That's why if you use a 90 degree and a 90 degree, you don't have any degrees left for that third angle. Okay, cool. Now, this video actually has 2 pages. So, go to the second page. Sorry, I'm going to stop. I'm going to make a different video because I'd rather have 2 short videos.